Okay, this section we're going to be looking at increasing and decreasing functions. But let's really define what increasing and decreasing means before we get started. Okay, so I'm going to type this here. This is what we can say increasing is. We're going to say assume f is defined on an interval I. F, the function is increasing on an interval if whenever a and b are in f, a and b are in the function, and a is less than b, then f prime of a is going to be less than f prime of b. Okay, so let's just think about what this means graphically. What's going on here? Okay, so we've got a function, and let's say our function is something that just goes like this. Okay, and we're looking at from A to B. Now, first it says that A has to be less than B, which on a number line it is. Then it's going to be increasing if f at A, right here, is less than f at B. Okay, so this is considered to be increasing. Now also think about this. So what does that mean about the slope of the derivative here? Increasing also looks like first derivative is positive. Okay, so that's an important conclusion to draw. Functions with a positive derivative that is where it is an increasing function. Okay, so what I would like you to do on Google Classroom, I've given a question, is how would you modify this definition right here? So take this exact definition, but modify it to describe if f is decreasing on I. So change this word right here to decreasing, and then make any changes to the conclusion of this sentence. So increasing would change, and then make any changes that you think should be made to this portion and upload that to the video. Okay, so now let's dive into an example, and basically we're going to be asked, where is the function increasing? So where is f increasing and where is it decreasing? Okay, and we're going to look at the graph of f of x equals x to the fourth minus 6x squared plus 1. Okay, and we're going to use analytical methods. In the end, we'll graph this and we'll see what the graph looks like. Okay, so the first thing I'm going to do is take the derivative, because I know that the first derivative is going to give me my critical points. So I need first derivative is going to say 4x cubed minus 12x. Okay, and there's no places where it's undefined, where the function's the first derivative is undefined. So we're going to set this equal to 0. I'm going to factor out a 4x. That's going to leave me with x squared minus 3. Okay, so zero product property is going to tell me that x is going to equal 0, or x squared minus 3 is going to equal 0. So x squared is going to equal 3. So x is going to be plus or minus the square root of 3. Okay, so that's going to give me 3 critical points. Okay, I'm going to have a critical point here at negative square root of 3. I'm going to have a critical point here at 0. And I'm going to have a critical point here at the square root of 3. So basically, I'm going to end up with 4 regions that I'm going to be analyzing. I'm going to be analyzing this region. Okay, so I've got 1, 2, 3, 4 regions. Okay, so we know that the only place a derivative can change signs is at critical points. Okay, so let's write that. The only place a derivative can change signs are at critical points. So we need to see if there's a change here, and we need to see if they're positive or negative, okay? So we are looking for values. If it's decreasing, we're going to be looking for when the first derivative is negative, okay? And over here, we're going to look for it's increasing when the first derivative is positive, okay? So let's pick some values, okay? If I plug in f prime of 2, okay, that comes out equal to -8. So I have a negative value here, okay? So if I plug in -2 into the first derivative, I get -8, okay? If I plug in f prime of -1, that gives me +8. So I've got a positive value here. If I plug in f prime of 1, that gives me a value of -8. So that's negative, okay? And then if I plug in f prime at 2, that gives me +8, okay? So now I know where the function is increasing at these two values, okay? The function is going to be increasing when the first derivative is positive, here and here, and the function is going to be decreasing when the first derivative is negative, okay? So I'm going to write this in a summary here and say f then is increasing using interval notation. I'm going to say it's increasing. It is not increasing at the point. It's a critical point there. So I'm going to go from -√3 to 0, and it's not at 0. And then I'm going to go from the square root of 3 to infinity. I'll be honest, your textbook, hopefully Math Excel is okay, but your textbook is inconsistent and sometimes puts brackets here, and we have proven that to be wrong. We need parentheses because it does not include the square root of 3. Okay, and where is f decreasing? We're going to take those values where it's negative, so it's going to be from -infinity up to negative square root of 3, and then it's going to be from 0 to the square root of 3. Okay, now what I'd like to do is look at the graph of this. Okay, so in order to find the graph, I need to graph on the calculator here. And we're going to graph this function. And we're going to see what's going on here. I'm going to slide this over to the side here. Okay, so we're going to look at y equals okay, I plugged in the function x to the fourth minus x squared plus 1. Okay, we're going to graph it. Okay, so now looking at this graph, we said that it was increasing from negative square root of 3, and if I press trace, I've got negative square root of 3 is right there. So it's increasing from -3 to 0, and it's increasing from the square root of 3. If I press trace, that's going to give me second square root of 3. It's going to give me that value over there to 0. Okay, so that works out well. It's increasing from here to here, and then it's decreasing on this section of the graph and from here to here. Okay, that's nice picture, matches with your final answer.